Good day everyone, I'm Kavin Ilangovan and I will be presenting about my final year project, that is TomatoHelp, in this video. My project is an IoT-enabled tomato crop web application designed to monitor key environmental conditions in real time. It is developed to assist tomato farmers in organizing different stages like sowing, care and harvesting. It also incorporates tomato avatars and automated systems to enhance engagement. The problem statements are the absence of real-time monitoring system for key parameters like soil moisture and temperature results in uninformed decision making, causing reduced crop yields and unnecessary resource use. And the second one is manual watering systems for irrigation and fire are inefficient, leading to resource wastage and delayed responses during emergencies. And the third one is existing systems lack interactive features, making farm monitoring less effective. The system objectives are to monitor the environmental parameters such as temperature, humidity, soil moisture and gas level, to design an automatic watering system for irrigation and early fire response, to provide a web-based platform with interactive responses using emoji-style tomato avatars that display condition-based messages like "I'm thirsty" for more engaging user experience. Proposed solution. There are 3 stages. The first, sowing stage. For sowing stage, there are 2 things to consider: soil and climate readiness. Sensors such as DHT22 for temperature and humidity and soil moisture sensors provide data to identify optimal sowing conditions. And then smart alerts. When conditions are ideal, the system sends a real-time notification to the farmer through the web dashboard with appropriate tomato avatar for more engaging experience. The second stage, which is crop care stage, it has 2 functions. Automated irrigation. A relay-controlled water pump is triggered automatically based on live soil moisture readings, ensuring water is delivered only when needed. Second one is environmental hazard detection. The MQ2 sensor detects harmful gases, allowing early fire threat identification and triggering automated water dispersion. As for the harvesting stage, record keeping is a very essential thing in this module. Manual data entry. Farmers can log key harvest details such as date harvested, quantity, quality of the tomato harvested. And then they can also upload a photo for future reference and data archiving. That is, all records are stored securely using Firebase services and can be retrieved for future analysis and reporting. TomatoHelp has a few modules in its application, which are environmental dashboard module, sowing module, care module, harvesting module. And under care module, there are 2 submodules, which are general care module, emergency care module. System architecture. It has data layer, business logic and individual user. It uses React.js and then Firebase for database and React for front end. And as for the logic, it uses a C++ language. Impact and benefits. The first one is efficient resource management. Automated irrigation ensures water is only used when necessary, minimizing waste and supporting consistent crop hydration. Second one is real-time monitoring. Farmers receive continuous updates about field conditions, enabling faster responses to adverse changes like fire risks. Improved decision making. Accurate, up-to-date environmental data supports more informed decisions at each farming stage from sowing to harvest. Enhance productivity. By reducing manual effort and delays, TomatoHelp enables farmers to increase yield quality and quantity. Finally, data-driven record keeping. The system simplifies farm reporting and planning through an organized digital archive of crop history. Entrepreneurship opportunities. Target market expansion. TomatoHelp is ideal for small to mid-sized farmers, especially in developing regions who need affordable smart farming solutions, especially controlled environments such as greenhouses. The second one is hardware-software bundling. The system can be commercialized as a package including IoT hardware and access to the web application. Thirdly, subscription-based revenue model. A freemium pricing strategy can be adopted with basic features offered free and premium tools like alerts and analytics available via subscription. Scalability across crops. Though designed for tomatoes, the platform's architecture can be adapted for other crops, broadening its market potential. Welcome to TomatoHelp. Let's go to the environmental data. Okay, we have all these parameters. These values are real-time data. That means I can control these values using this IoT setup. So this is the soil moisture sensor. So if I remove it from the water, you see, it shows 0%. That means it's dry. If I put it back into the water, it shows 67%. So the data will be updated every 3 seconds actually. So this is the temperature and humidity sensor. I'm gonna blow on it. As you can see, the humidity level is increasing and the temperature has risen just a little bit. So here we have the sowing readiness under sowing module. So it shows the real-time data. Like I can actually control the data if I remove the soil moisture sensor from the soil. Yeah, it shows like that. And then since the ideal range is not achieved, it shows all bad. So it says I'm not ready for sowing. If all are good, then it will show I'm ready for sowing. And let's move on to the care module under general care. And since none of the status is in the correct ideal range, so it shows I'm not well taken care of, I hate you. So under emergency care, okay, since the emergency care, under emergency care, the current value is 13, which is within the range. It shows chill, no fire, I'm cool. And for the harvest data, the module, we can actually type fill in the data. We can fill up the data like so. 1 kg and looks good. Add juicy, and we can also choose image and submit. An image is added. You can actually delete the image also if you want. And currently the soil moisture shows 0, so that means water is needed. So I have the IoT setup here, and this is the water pump and this is the pipe. So I'm going to put the battery, and